So today we are doing the cathode ray oscillator. The aim is to find the frequency and the voltage of the AC signal and to observe the Lissajous figure and find the phase difference. The whole experiment is basically divided into three different parts, where we first find the measurement of the AC voltage, then we find the frequency, and then in the last part we find the phase difference. Right now we'll start with measurement of AC voltage. So we are gonna use this audio oscillator, the CRO, and the multimeter for the experiment, for the first part of the experiment. The connections are very straightforward. From the audio oscillator you connect to the from the red wire of the oscillator you connect to the channel 1 of the CRO, and from the black of the oscillator you connect to the black of the CRO, and from the multimeter similarly the red goes to the red and black goes to the black. After switching on the apparatus, make sure that the oscillator is at some fixed value. I have taken 1 kHz in this case, and then set up this point to this center by using these knobs. This will go up and down, and this will go along the x-axis. Before setting up, make sure this is in the xy plane, and after this comes to the center, turn it back to this minimum to the other side. You'll see a wave moving like this, and you change from ground to AC in channel 1, and to get the sine wave basically you just change the voltage, and you change this time per division until you get a sine wave, a proper sine wave like this. And so to find the AC voltage, we use this table, and this corresponding table values is written down from this multimeter, which we obtain by changing the amplitude of the oscillator, and then whatever value we get we write it in the first column of the table. Now to find the x, y values, we use the graph over here, and your x value is basically this variable voltage, and your y value is basically your peak to peak voltage. So using the graph we find the units, and using this we find the x value, and then we multiply both, we get xy, and then we plug in into this formula and find the value using the formula, and you will find that this and this is almost similar. Now for the second part of the experiment, the connection remains the same, but instead of finding the voltage we are finding the frequency. Before finding the frequency, make sure to set this multimeter again using the amplitude over here to some value greater than 2 volts, which will not be less than 2 volts, and then after keeping this constant, we change the frequency over here, and correspondingly write the frequency over here. And using the graph again, instead of going from peak to peak, we go from horizontally. So from this point to this point, we find the x value, and your y value will be nothing but the values over here. Make sure to read the values properly, and then you plug in the table again, and similarly these first column and the last column should be same. Okay, so now for the final part of the experiment, we just follow the circuit given over here, and I have already made the connections. So basically you connect, one thing to keep in mind is all the negatives should be together, so it should be grounded together, and the rest of them are in series with each other. So from this red goes to channel 1 of red, and from channel 1 of red goes to the capacitor, from capacitor it goes to the resistance box, and from resistance box it goes to the red of the channel 2. Now while taking the readings, we will either change the resistance value, the capacitance value, or the frequency value, and observe the Lissajous figure which we will get. So after making the connections and all, we first change this to dual mode, the CRO to dual mode, and for again we recalibrate it by keeping channel 1, channel 2 to the ground, and using again the x-axis and y-axis to make this dot appear to the center. So for the experiment, we are gonna find the Lissajous figure by varying the resistance or the capacitance or the frequency, and correspondingly we'll find the B and the A value, and again we find the phase difference using that. So to obtain the Lissajous figure after making the connections, I have removed some 500 ohms from this, and I have given some capacitance. I have calibrated this to this point, and to get the Lissajous figure, just change the channel 1 to and channel 2 to ground. You'll get a Lissajous figure. To measure the values of B and A, we basically use the graph over here again, and the value of B is basically from the center of the Lissajous figure to the point where the figure cuts the y-axis, and value of A is basically the peak of the figure to the x-axis. So we fill in these values by changing the resistance or the capacitors or the frequency, and we find the corresponding B and A and use it in the formula sin theta is equal to plus or minus P or A, or theta value is equal to some value we get. And by formula we know that tan theta is 1 by 2 pi r FCR, and we find the corresponding theta. Make sure again this column and this column are almost similar, and that's it, your experiment is good.